Hi, welcome to Physics 4.2 on momentum and impulse. Today you actually get to solve problems. Let's start talking about momentum. Momentum is inertia or mass in motion. Momentum carries the notion of both mass, which is inertia, and velocity, which is motion. Okay? Momentum is mass times velocity then. So momentum is in the same direction as velocity, and it has to be. If the velocity goes a different direction, the momentum then wouldn't really exist. Momentum, therefore, is a vector because it has a direction. An example, a 20 kilogram object moving at 10 meters per second has a momentum of 200 kilogram meters per second. Something massive moving fast carries a lot of momentum, but something really massive moving not so fast can still carry a lot of momentum, mass times velocity. And something really, really little that doesn't have a whole lot of momentum unless it goes really, really fast, like a bullet. So equivalent momenta. A bus that has a mass of 9,000 and velocity of 16 has a momentum of 144,000 kilogram meters per second. Similarly, a car has a mass of 1,800 kilograms and a velocity of 80 meters per second, they're going way too fast, also has a momentum of 144,000 kilogram meters per second. That means that car is going to be just as hard to stop as that bus. And then you get a train. Train has a massive mass of 36,000 kilograms, but it's only going at 4 meters per second. It still has an equivalent momentum of 144,000 kilogram meters per second. All three of them would take the exact same amount of force in order to stop them. Impulse, remember that you're given momentum is mass times velocity. If velocity changes, momentum changes, and acceleration occurs. But we know a couple things. One, in order for acceleration to occur, a force has to be applied. If a given force is applied over a long period of time, you get more acceleration. Impulse is a measure of how much force is applied for how much time and is equal to the change in momentum. So impulse equation is force times time, or F times t. A force applied over time will change the momentum of an object. So remember this relationship, the impulse-momentum theorem says that the impulse is equal to the change in momentum. It shows that inverse relationship between force and time. A long force over, or a lot of force over a short period of time, or a little amount of force over a long period of time. So force can equal mass times the change in velocity divided by time. So look at these two impulse relationships. Both of them have the same momentum, but if the truck hits a hay bale, it's going to increase the amount of time, which decreases the force. If it hits a wall, it's a lot of force over a little time. Impulse-momentum relationships also tell you why rifle and cannon barrels are so long. For the same force, why is the speed of a cannonball greater when it's shot from a cannon with a long barrel? Well, since time is directly related to velocity, and force and mass are held constant because same amount of force, same amount of mass, the longer the cannonball is in the barrel, the greater the velocity. You could also say that the force acts over a longer displacement and thus is more work. And we'll get to that next unit. Impulse examples. Changing momentum that is small force, long time, or a lot of force over a little time. Follow through increases the time of the collision and the impulse. In football, a defensive player applies a force for a given amount of time to stop the momentum of an offensive player with the ball. This is why wrapping up in football is important. In a karate chop, same thing. These are momentum examples. So to increase the momentum, the impulse of the bat decelerates the ball and accelerates it in the opposite direction very quickly, right? But follow through is important. Otherwise, you're bunting. Decreasing momentum, it takes an impulse to change momentum. Remember, impulse is force times time. So if you want to stop something's motion, you can apply a lot of force over a short time or a little force over a long time. Remember that things tend to break if you apply a lot of force to them. Remember the truck? Think of a trampoline, somebody jumping out of a building, right? We want to increase the amount of time before they hit the ground. But a rocket, we want to decrease the amount of time. That increases the force. If a boxer moves away from a punch, he extends the time and decreases the force while stopping the punch. If he moves towards the punch, he decreases the time and increases the force. It's an inverse relationship. Airbags extend the amount of time over which impulse is exerted and therefore decrease the force. If you were to hit the steering wheel instead of the airbag, which you're going to hit the steering wheel too, the airbag simply decreases the force because it increases the amount of time before you hit the steering wheel. A karate chop hitting the bricks with a sharp karate blow very quickly maximizes the force on the bricks and helps them break. So here's an example. Jennifer, who is a mass of 50 kilograms, is riding at 35 meters per second in her little red sports car when she suddenly slams on the brakes to avoid hitting a deer crossing the road. She strikes the airbag that brings her body to a stop in 0.5 seconds. What average force does the seatbelt exert on her? Well, notice that in blue is what was given to you. Mass in kilograms, meters per second. Stop is also meters per second, seconds, and force. That's what was given in blue. You filled in the rest of it. Mass was 50 kilograms. The velocity was 35, and that is the V naught was 35. The V is 0. The time was 0.5 seconds, and we want to find the force. Well, remember that force times time is equal to mass times a change in velocity. Substituting in all the values that we know and solving, we get an average force over her body from the seatbelt of 3,500 newtons. You're going to be doing lots of problems today in class. Thanks for watching.